In number 20, it asks you for a correct factorization. A factorization is two or more things that multiply together to give you what we started with. So we want to find two things that multiply together to give us this quadratic binomial. First thing I'm going to do is look for a GCF. What can I divide both of these things by? And the answer to that question is a lot of things, but the greatest thing I can divide both of them is 16. So I'm going to have 16 times 4b squared minus 9. Now I notice that this is a difference of squares, which means this is something that's squared, 4b squared is something squared, and so is 9. When I have a difference of squares like I have here, I'm going to leave the GCF where it is, and all I have to do is take the square root of this. What can I multiply times itself to get 4b squared? That's a 2b and a 2b. What can I multiply times itself to get a 9? That's going to be a 3 and a 3. I'm going to make one of them positive and one of them negative, and if I multiply these together, I get exactly what I started with. Now, this is one example of how you can factor this. I could also have factored this just by doing that step of difference of squares at the beginning. So notice that 64b squared is a perfect square. So I could write that as an 8b and an 8b, because that multiplies to give you 64b squared. And 144 is also a perfect square. I could write that as a 12 and a 12. Put a plus and a minus, and you'd have a correct factorization there also. But notice how both of these have common factors. So there's different ways to factor them, but this is the factored completely way. For number 21, we need to solve the problem and find all real solutions. So in number 21, we've got to get rid of this square root in order to solve for x, but before I can take the square root away, I've got to get the square root all by itself on one side. So I'm going to subtract x from both sides, which leaves me with the square root of 2x plus 1 equals 7 minus x. Now the opposite of a square root is squaring. So I'm going to square this side of the equation, and I'm going to square this side of the equation. When I square the left-hand side of the equation, squaring and square root are inverses, so they cancel each other out. I get 2x plus 1. When I square this side of the equation, a lot of people forget that 7 minus x is equal to 7 minus x times 7 minus x. When you square something, you multiply it times itself. So this gives me 49 minus 7x minus another 7x plus x squared. And if I combine these like terms, on this side I get an x squared minus 14x plus 49. Now this is a quadratic equation because I have this x squared in it. So I need to get everything on one side of the equation, so I need to subtract this from both sides. That's a minus 2x on both sides, lining up like terms, and a minus 1 on both sides, also lining up both terms. So 2x minus 2x is 0, 1 minus 1 is 0, so I have 0 on this side. On this side I have x squared minus 16x plus 48. To finish solving this, I'm going to factor. What multiplies to give me 48 and also adds to give me negative 16? That's negative 12 and negative 4. So x minus 4 and x minus 12. And now we set each of those factors equal to 0. And we get x equals 4 and x equals 1. Whoa, how'd that end up at 1? X equals 4 and x equals 12, sorry. Now the issue is that not both of these solutions work necessarily. In order to see if they really work, we have to check them in the original equation. So I'm going to clear a little bit of space off so I can do that. Let's check this solution using green. If I do the square root of 2 times 4 plus 1 plus 4 equals 7, is that true? Well, this would be the square root of 8 plus 1 plus 4 equals 7. That's the square root of 9 plus 4 equals 7. And that's 3 plus 4 equals 7, which is true. So 4 is a solution for this equation. Now let's clear off space again and check the 12. We'll check the 12 in pink. We'll do the square root of 2 times 12 plus 1 plus 12 equals 7. 2 times 12 is 24, and 24 plus 1 is 25. The square root of 25 is 5. So now I'm going to bring down the rest of the equation and see if this works. 5 plus 12, as you know, is not 7. So 12 is not a solution to this equation. So the only answer that works is the 4 that we had before. Number 22 is pretty easy. We're just going to simplify the expression, which means we need to combine like terms. The reason people miss number 22 and problems like it is because they're not very careful about this minus sign. This minus sign means that we're subtracting everything in these parentheses. So you got to be really careful when you do that. One way to avoid making a mistake is to rewrite this problem distributing that negative into the parentheses. So that would be a minus 10x cubed, a minus negative 8xy squared, and a minus negative 12y cubed. So the reason I did minus negative is because of the minus that's outside along with the minuses that are inside. Remember, 2 negatives make positive numbers. So I've got all of this stuff in addition to what comes out of these parentheses. And that doesn't have a negative in front of it, so I'm just going to keep all of these exactly the same as they are. Now I just need to look for like terms. Are there any other x cubes? Yep, here's one. If I combine those, I get a negative 5x cubed. Are there any other xy squareds? Here's one of those. It's positive. 2 of them plus 8 more is 10 total xy squareds. And then finally, remember this was a minus 4y cubed, and here's a positive 12y cubed. So altogether, that's 8y cubed. And that finishes that problem for simplifying the expression. We've combined all the possible like terms. In number 23, it asks us for the zeros of the function. Remember, synonyms for zeros. Zeros are the same thing as solutions, which are the same thing as roots, which are the same thing as x-intercepts. So, if we're looking at a graph, we're looking at the x-intercepts. It's kind of hard to tell exactly where they are. If they're whole numbers, it looks like -1 and +1. So I would say x equals -1, x equals +1. It looks like they might be a little bit less than +1 and a little bit greater than -1. But in this case, we're just going to go with those two values unless we have multiple choice answers that we can work with to get a better idea.